How does it happen? What does it all mean?
Let's find the answer.
How does it happen?
Let's find the answer.
Day 37 of my science quest. I'm out on the ice today because I'm learning about the force of friction. People have such a love-hate relationship with friction. We want friction when we need the brakes of a car or bike to stop. On the other hand, we try to reduce friction in a car engine by adding motor oil, and when doing something like skating on ice. So, it seemed like a good question for my trip today. What do we really know about friction? I always thought of friction simply as two things rubbing against each other. But open a textbook and you'll learn that and more. Friction is a force that opposes motion between two surfaces in contact. It exists whenever two things make contact. When you bowl a bowling ball, there is contact between the ball and the wood of the bowling lane. This causes friction that slows the motion of the ball. If the lane was long enough and there were no pins at the end, the friction between the ball and the floor would eventually stop the ball altogether.
What does it all mean?
Friction always exists whenever any two things touch, like car tires and the road. Rubbing a car with a cloth to dry it means using friction. The amount of friction there is between two objects depends on two things: how much pressure is pushing them together and how uneven the surfaces of the two objects are. Even though certain objects in our lives, like bowling balls or ice, appear to be perfectly smooth, they aren't. Nothing is. On a microscopic level, every surface is rough and uneven. Think of my bowling ball again. The weight of the ball pushes down on the floor, and the two surfaces make contact. Or when I skate, my weight presses the skates down against the ice, but because the blades in the ice are pretty smooth, I'm able to glide along. If my footwear is a bit rougher, say golf spikes, there's a lot more friction. So much that I can't slide at all. Here's what I learned about friction so far. Friction is a force that opposes motion between two surfaces in contact. Friction exists whenever two objects touch each other. The amount of friction is determined by A, how much pressure is pushing the two surfaces together, and B, the roughness of the two surfaces. All surfaces are rough and uneven on a microscopic level, even though they may look smooth to us. Friction is a big part of our lives, and there are a few different kinds. When two objects rub or slide against each other, it's called sliding friction. Like when I was drying my car, sliding the cloth over the surface of the car, or pulling this ice block. The surface of the block slides over the surface of the rink. Sliding can produce a lot of friction. That's because the bumps and jagged edges of the two surfaces actually grind against each other. I'm here at this motorcycle raceway to see another kind of friction in action. Rolling friction. Rolling friction happens when two surfaces come in contact, but there's no sliding. One surface rolls over the other. There is less friction when the objects roll than when they slide. Just think of the friction that would be created if these motorcycle tires had to slide across the track instead of roll. Or if my bowling ball was square and had to slide down the lane. People use rolling friction all the time to reduce sliding friction. That's why we can rollerblade. If you don't believe me, try rollerblading in sneakers sometime. Rolling friction is even used inside wheels to make them turn with less friction. Inside most wheels, on your bike, a motorcycle, a car, are a bunch of small round metal pieces called ball bearings. These ball bearings sit between the wheel and the axle, where there would be a lot of friction. Because they roll as the wheel turns, the friction is reduced, and the wheel turns with much less effort. For a motorcycle racer, knowing the difference between rolling and sliding friction is critical. For the bike to move quickly off the start, the tires need to roll across the pavement, rolling friction. If the tires slip, sliding friction, the bike doesn't move as fast. But that doesn't mean that sliding friction is a bad thing. Take a look at the brake discs on this motorcycle. The disc is attached to the wheel. When the rider pulls the brake lever, a brake pad presses hard against the disc, creating a tremendous amount of sliding friction. So much friction that it slows down the wheel and stops the bike. We know that friction is based on contact, right? The more contact, the more friction. Well, here's a bit of friction trivia about tires. They need to have contact with the ground so that there's enough friction to move you forward. But if tires are underinflated, not enough air, more of the tire makes contact with the ground. More contact, more friction. And the more friction, the harder it is to move. This is why cars or motorcycles with underinflated tires use more gas, and why bikes with underinflated tires are much harder to pedal. So far we've talked about friction being created when there is contact between solid objects. But it also applies to things that aren't solid, and this is called fluid friction. I can't think of a more fun way to show it than in the sport of water skiing. We know water is a fluid, but actually, so is air. A fluid is any substance that can change shape very easily and move around other objects. Fluid friction is the force opposing the motion of fluid over an object. Remember my car wash? Spraying the car with water produces friction between the car, the dirt, and the water. Obviously, to go water skiing, you have to start in the water. The fluid is all around you and there's a lot of friction against your body and the water ski. The key to water skiing is to reduce the friction enough so you can move fast. That's where the water ski comes in. It's made so that the water slides easily over the ski. When a skier is pulled by a powerful boat, the pull of the boat lifts him out of the water and he's off on a wild ride. By shifting his weight on the ski, he can control the amount and direction of the friction to make turns. And the water isn't only making contact with the ski. There's obviously fluid friction happening as the boat pushes through the water too. The only reason the boat and the skier can keep moving is because the force of the boat's engine is stronger than the force of the friction. If the engine were to quit, the fluid friction would immediately start to slow them both down until they stop moving. I discovered that scientists have a way of measuring how much friction is created by different kinds of surfaces, like asphalt on a road or ice. The term they use is mu. Not that kind of mu. It's an ancient Greek letter. If a surface produces a lot of friction, like asphalt, it is said to have a high mu factor. If a surface produces very little friction, like, say, polished wood, it is said to have a low mu factor. This can be calculated with very specific numbers, but the important thing to remember is that we choose what surfaces should be used for a particular job based on its mu factor. For example, Since asphalt has a high move factor, it's a good surface to use on roads where we need plenty of friction. On the other hand, it makes a lot of sense to use a very smooth waxed wood surface for a bowling alley. Low move factor, less friction. The metal parts inside a car engine have a pretty high move factor. When the engine runs and the parts rub against each other, there's a lot of friction inside. This can damage the engine. That's why we add motor oil, which has a low move factor. It reduces the friction inside the engine. This is called lubrication, and any substance used to reduce friction between two surfaces is called a lubricant. Most common lubricants are fluids like oil, but there are some powdered or even solid lubricants. No matter what form they're in, lubricants are always used to reduce friction. In this case, less friction, happy engine. Here's an experiment you can do to test different ways of using lubrication to reduce friction. You'll need an object to test, say a wood block with an eye screw attached. A surface to test on, we'll use a wooden board, a spring scale, and some tape. And you'll need some substances to experiment with, some small wooden dowels, several strips of coarse sandpaper, a tub of wax, some cooking oil. First, create a chart to record your data that lists the 4 different surfaces you'll be pulling your block across: plain wood, dowels, sandpaper, wax, and oil. Lay the board on a flat work area and divide it into 2 lanes. Now place the block at one end of the board in the first lane and attach the spring scale using the eye screw. A spring scale measures the pull between 2 objects. We'll use it to measure the friction between the block and the board. Slowly pull the block toward you. As the block slides across the board, have a helper note the reading on the scale. It's important to keep pulling at the same steady speed. Mark the reading on the chart under wood. This is your standard. Wood sliding against wood. Next, lay the dowels across the board and place the wood block on top of them. Pull the block across the board again as it rides on the rolling dowels. Mark the scale reading on the chart. How does it compare to the first reading? Now, tape the sandpaper strips down the center of the board. Pull the block again over the sandpaper and mark this reading on the chart. Remove the sandpaper and rub the wax all over the center of the first lane. Make sure there's plenty of wax. Pull the block again, noting the reading on the scale. And finally, in the other lane, pour a line of cooking oil down the center and pull the block one more time. Note this last reading on your chart. We know that the amount of friction depends on the weight of the block pushing down and the roughness of the 2 surfaces. Of course, the weight and roughness of the block stays the same, so the only factor changing is the roughness of the surface under the block. Now compare your results to the first reading, wood on wood. The sandpaper resulted in more friction because its surface was rougher than the board, not a very good lubricant. The wax produced less, a bit less friction because it filled in the board's rough spots, making it smoother. The cooking oil also produced less friction because it's a fluid, and the dowel's rolling friction generated the least friction of all. Remember, fluid and rolling friction are both less than sliding friction. You've just demonstrated several ways that lubrication can be used to reduce friction. Way to go! You know, even air produces friction as it hits an object. Remember we said earlier that air is actually a fluid. When the wind turns a windmill, the air is pressing and rubbing against the blades. When you look at really cool race cars, you notice how they are always designed very low, sleek, and curvy? The reason is because the designers know that friction from the air, called wind resistance, pushes against the car and slows it down. In the diagram, you can see how the wind hits the race car and slips over it easily. If the car were more bulky and square, the air would make more contact, causing more friction. This car would not be able to go as fast as the race car, even if they had the same engine. Like race car designers, the people who design airplanes want to reduce the friction between the surface of an aircraft and the surrounding air. A quick look at the shape of a modern jet, opposed to some of the more fanciful creations from an early airplane design, and you can quickly see that the smooth, curvy shape of a modern jet plane is designed to slip through the air with the least resistance possible. This is one reason why jets are able to travel at such high speeds. So we've seen three kinds of friction so far. Sliding friction, two surfaces rubbing or sliding against each other. Rolling friction, one object rolling across another without sliding. And fluid friction, a non-solid surface like water or air pushing against another surface. They're all around us, wherever things are in motion. But there's another kind of friction that requires no motion at all. Static friction. Static means no motion. It happens whenever two objects are touching, but not moving. It's that simple. As the deli guy builds this huge sandwich of Swiss cheese, every slice of cheese presses down against the one under it. There's contact, but no movement. Static friction holds them in place. You seated in a chair, my feet on the ground, a car sitting in a parking lot. All static friction. We usually think of friction only when things are moving, like the blade of this slicer rubbing against the cheese as it cuts. But without static friction, nothing would ever stay still. Things would always be moving all over the place. Okay, so maybe this is a little too much static friction. Here's a sport that relies heavily on friction, rock climbing. You know that the force of gravity affects everything around us? It's why rain falls, or apples drop from trees, and when a dog jumps, it lands back on the ground. Gravity also pulls us down to the ground, and when you climb a mountain, you are trying to overcome the pull of gravity. The secret of climbing up the side of a rock cliff is friction. Climbers have special shoes that are designed to provide maximum grip or friction against the rock as they climb. The same goes for their hands. They use special powder on their fingers to increase their grip. The shoes and the powder help create more friction and prevent them from slipping. And the last thing a climber wants to do is slide, except when they want to get down the mountain. Then they use special ropes that can slide through their hands and ease them down slowly. Something we need to know about friction, besides what it is what it does. Friction creates heat. We know that friction is caused when two surfaces come in contact. When this happens, the surfaces get warmer. You use this idea every time you rub your hands together. The more friction, the more heat is created. Once upon a time, the only way people made fire was by rubbing sticks or stones together. If you use the right materials and rub them together just right, enough heat will build up so that a fire starts. As you can see, I'm not having much success. But the same idea is behind the more modern-day method of lighting a match. When I slide the match head over the rough surface on the side of the box, the friction creates so much heat that the match starts to burn. Well, that's the end of my science trip for today. We learned a lot about friction. Friction is a force that opposes motion between surfaces in contact. The amount of friction there is between two objects depends on two things: how much pressure is pushing them together and how uneven the surfaces of the two objects are. Three kinds of friction happen when there is motion: sliding, rolling, and fluid friction. Static friction happens when objects are touching, but there is no motion. Friction creates heat. To reduce friction and heat, we use things like motor oil in car engines and ball bearings in wheels. So much of our lives is about using or losing friction. Most of our music comes from friction, like a bow rubbing against the strings of a violin, or air as it pushes against the inside of a harmonica. So long, your fellow traveler.